So to merge the two datasets, we need to make sure that the two datasets have at least one common variable. And if they're string, then categories must have same spelling. That is, if the common variable is string, then they must have same spelling. Otherwise, it won't be a successful merge. The common variable must have the same name, so same variable name, in this case subject sub. If merging two panel datasets, then we will need at least country and time. So you will need one time variable and we will need another variable for the individual entity, or which is typically a country. Alright, so now we are going to do merge using temp files. So Tempfile, it basically creates temporary files in status dataset instead of creating hard or physical files in our folder. So this is very helpful when we are working with big data or large data sets that consume a lot of memory or a lot of space in our hard disk. So this is why people prefer the merging using Tempfile. So first thing is we're going to sort subject. So anything we need to do before merge, we need to sort our variable, which is going to be the merging variable, the common variable between the two data sets. Okay, so let's create a temp file, and the name of the temp file is going to be median, and then we are going to save the name median. What it does, it creates a temporary file called median, and it saves whatever data we right now have and into the temporary file. Now you can see that it says invalid file specification. So one reason, so the reason behind this is we cannot run line by line commands when using temporary files or storing temporary things in the temporary memory. We have to run this whole block of code altogether for this to work. So I'm going to run sort subject. I'm going to create a temp file median, save it, and then I'm going to open the first dataset that we created, sort subject in that dataset, create a temp file and name it main data. Save it. I'm going to use median, which is the smaller data set that we have, and we're going to do one-is-to-many merge using the common variable sub. So let's run this whole block of code all together, and now it works. And it says that it has matched 100,000 observations where 0 are not matched. So let's check the merged data set. And we can see that we have successfully merged. We have the median scores for each of the corresponding subjects, and we have age, score, name, row number, and we also have additional variable called merge. So let's drop the merge and the ID variable. So now we can conduct data analysis. So the first thing typically that we need to do is create dummy variables. So now let's create a dummy variable that corresponds to each subject. So we have 3 subjects. So what I'm going to do is I'm going to use the levels of command. So levels of subject, this is our variable, and we're going to store those values in a local macro called levels. So again, we have to run this whole command block altogether for this to work. And then we're going to run a loop where for each value that has been saved in the local macro levels, it's going to quietly generate a dummy variable and give it the name dummy and then the name of L. And then this is going to be 1 if L is equals to the subject name, and this is going to be 0 otherwise. Okay, let's take a look. And we can see we have dummy for econ, for math, for physics. So for econ, this is econ and it has 1. This is math, so econ is 0 but math is 1. And so it has successfully created dummy variables for each of the subjects. So notice one thing, that here when we are doing this evaluation of this expression, we are wrapping this L or our local macro L here in quotes, because the subject names are in strings. So by wrapping it in quotes, it's also converting it into strings. But let's say we had numerics. How would we do that? So first let's create another made up variable for year. So I'm just generating 3 years, 1980, 1990 and 2010. And now I'm going to create dummy variables for each year. So again, the levels of function is going to extract the unique values of the variable year and then assign those values to a local macro named levels. And then we're going to run a loop off of those values. Now let's take a look. And now what it has done is it has extracted the value of the years, which is the 3 years that we have, and then created 3 dummy variables. And notice that here we have not wrapped the L in double quotes as we had done in the case of the subject names. So the subject names were in strings, so we had to make it string, but here it's numeric, so no need to convert it into string. Okay, so now let's create labels on the dummy values where 0 corresponds to control and 1 corresponds to treatment, let's say. So first thing is we are going to define the labels that we are going to assign to the values. So this is different from giving variable labels. So we are going to give labels to the values of specific variables. So label define, let's give it the name dummy DUM. So 0 stands for 0 is going to be assigned for control, and 1 is going to be assigned to be treatment. All right, now label values, and the values of the variables that are going to be relabeled is going to be dummy econ, dummy math, and dummy physics, and it's going to take the labels from this DUM that we had defined in the previous line. So let's browse. Now we can see that these corresponds to zeros and ones, but the labels have been changed to be treatment and control according to the way we had defined. Right, now let's save this datasets for any future tutorials that we might do. So now we are going to generate summary statistics. So the quick thing that we typically do is run the command summarize, and I would have to reduce the font size for this to come out in a nicer structure, but let it be. So this is how we get general summary statistics. It gives us the observation, mean, standard deviation, minimum, and maximum for all of our variables. So let's say we would like to tabulate the counts of age by subjects. So we can use this command, by sort subject, tabulate age. So subject physics, it gives us the tabulation of age, frequency, and percentage and cumulative frequency. So we have it by each subject. Now let's summarize the scores by subject and let's say the dummy econ. So tabulate subject and dummy econ and summarize score. So what it does is now we have for each subjects, and then we subgroup it by this variable that's dummy for econ, and then we get the means, standard deviations, and frequencies of score. So this is the mean for all of those subjects which are economics, and all of those economic subjects which are the treatment. This is the standard deviation, and this is the frequency. This is the mean for all of those subjects which are math and fall into the control group under the dummy econ. Now we can generate similar statistics using a different command. I'm doing here for mean. So when dummy econ is equals to treatment and the subject is econ, the mean of scores is 29.9950, 99053, and we can match that here. So when the dummy econ is treatment and the subject is econ, we get this as the mean score. Same for math, 30 point something, and here it goes. So we can generate the same summary statistics in different formats as we want. We can add standard deviations and frequencies here as well. Now let's show the mean scores by different age groups. So we are going to now we are going to use the function or the command table. So table, the categories are going to be age, and the contents are going to be the mean of score. So we have mean scores by different ages. Let's show the mean scores by subject instead of the ages. So table category is going to be subjects, and contents is going to be the mean of the scores. Okay, now let's display the mean score and standard deviation of score, as well as the max and median of score by each subject. So we're going to create a table where the categories are going to be subject, the contents are going to be mean of score, standard deviation of score, max of score, and median of score. And this is a nice and neat way to summarize large data sets by different groups or categories. So we can display the above table that we just created right now in 2 decimal format. So just add this bit with the command format %10.2fc. So now we have the same things, but instead of having so many decimal points, we have 2 decimal places. So let's do it with more complicated categories. So show the mean scores by subject and age, but only for ages between 12 and 16. So we're going to sort the dataset by subject and then create a table where the category is going to be age. If age is greater than 12 and age is smaller than 16, and the contents of the table is going to be the mean score. And so we have the subjects, we have age, and we can see that we have age 13, 14, 15, so it's between 12 and 16, and we have the mean scores by subject for all of these age groups. Okay, so now let's show the mean and standard deviation of age and score, and also the 3 dummy variables, keeping 4 decimal places. So instead of 0.2 FC, we're going to make it 0.4 FC, and this time we're going to use the command tabstat. So when we have to tabulate multiple statistics, it's easier to use this command tabstat, and then you just write down whatever variables you want to have. If you have 10 variables, just write 10 variables here one by one, and then whatever statistics you want. And since all of our dummy variables of the subject have a similar naming structure, so if I write dum and then give a star sign, it's going to pull up everything that follows this naming structure. And you can see it pulls up dummy econ, dummy math, dummy physics, dummy 1980, 1990, and 2010. And it gives us the mean and standard deviations for each of these variables. We can generate even more statistics. So this is just an example: mean, median, standard deviation, variance, count, range, minimum, maximum. And in this case, I've just given 2 variables, score and age, so we can get all of these things. All right, now let's see how we can generate the correlation coefficient between 2 variables. So I'm going to use the pairwise correlation function, PWCORR, and getting the pairwise correlation between age and score. I also want to display the level of significance, and I want to give stars at a level of significance 0.05. So the correlation between age and score is minus 0.0040, and the p-value is 0.2098. So this is not statistically significant at 5%, so there is no star here. So let's say I change my statistical significance in this particular example 21%. Well, now I have a star here. So this is how we can display the correlation along with the significance, and also giving stars where we want. Now let's replace scores to be missing values if age is either 23 or 25. So if age is 23 or age is 25, so this is how we do an OR clause. We did an AND clause using the AND here, so where these both of these have to be satisfied. But in this case, if any of these satisfy, then STATA is going to use this command. And STATA recognizes missing values as .m. It also recognizes missing values as just dot. So both of these are recognized as missing values. So we can check if the operation was done correctly. So let's tabulate all of the ages for which scores are missing. So missing is another command that we can use. So tabulate age if score is missing, and we can see those particular ages are 23 and 25, exactly what we applied. Okay, now let's create a new variable. So this is where we come to the variable transformation part. So the most frequently used transformations typically in analysis is taking natural log or exponential or square roots. So let's generate a new variable called taking the natural log of score, or taking exponential of score, or creating square root of score. So very simple here, ln exp and sqrt. So we are almost done with the tutorial. So finally, let's aggregate the data to display the sum, mean, median, and of scores by subject, and then by each year. So before I do that, let's take a look at our dataset one time. So this is the data that we have. We have subjects, we have scores for each subjects, and we also have years. So I want to aggregate all of these things by just the subjects and the years. And after aggregation, I just want to have the mean and the median and the sum of the variable scores. So for this, we use the function or the command collapse. So the first thing that I want is the mean, and I want to name that variable as mean score. So mean score is going to be based on score. The second thing I want is the median, and I want to name it median score, which is going to be score based on score. So if you want the median based on some other variable, you can just use other variables. So let's say I want the median of age. So let's do median age, which is going to be based on age. And let's get the sum of total score. Name of the variable is going to be total score. It's going to be a sum, and it's going to be based on score. And I want to do this aggregation by subject and year. Let's run this command. Done. Let's browse. And we can see it has aggregated by subject and year. The mean score, the median age, and total score are all here. If we wanted to use frequency weight or analytical weights, it's pretty simple. Just add this bit, frequency weight, and whichever variable contains your frequency weights or analytical weights, just give that variable name. So this is how we can work with datasets in Stata, starting from cleaning and transforming it, and then generating useful summaries. I hope this video has been helpful for you. Thank you very much for watching. If you like my videos and find them helpful, then please support my work by subscribing to the channel.